Essex engine. I'm just pulling the crank out of it. That's 4.5 inch stroke. This is the crank that was in the first engine. It's not bad, but it needs a grind. It's got 12 thou bend in the middle. Just about to pull the counterweights off. This is 1-1's marked at the top, so looking at the crank looking for the front of the crank on the left-hand side. 1-1, 1-2 on the right-hand side, 1-3 on the right-hand side, 1-4 on the left-hand side again. So I'll pull this apart, put it in the tank. Just straightening the shaft here. Got it in the press, so I can just spin it over. It's sitting in V blocks. Sitting in V blocks, I can just spin it over and measure any out of round or any bend, and then find the low spot, give it a press in the press, bending about 175 thou before it actually gets into the plastic. So it's but it's come up straight now. I've got that within 2 thou, so I can grind this. I can grind the mains nice and straight without taking too much metal off, and then I'll close the bearings down, line bore the bearings to 2 thou clearance, and hopefully that'll be the crank fitted. Okay, I've got all my shims and everything cleaned up and sorted, and what I've done, installed the bearings and then give them a close on the cap grinder so that I'm completely flat. I've made sure I've ground completely flat right across the parting face and across the parting face of the bearing, so that when I put the shim on this, the shim will not only sit on the cap, but it'll also hold that bearing, hold that parting face of the bearing, and give correct crush to the bearing. So that way I'm going to be able to line bore it and know that the bearings aren't going to move. This is Hudson engine. I've just finished line boring it. So basically I've put a shim under the main bearing there on the block to try and shim the bearing up. I've then taken some shims out of the parting face of the cap, but I've also stripped the cap back to get the edge of the bearing nice and level. The other thing to keep in mind is that the edge of these shims sit right over onto the parting face of the bearing, so they lock the bearing in and give it the right crush. So that's all really good. Basically I've closed so I've lifted this bearing up 4 thou, cut the caps down and closed them up a fair bit, probably about 15 thou. I had about 12 thou clearance before I started. The crank was worn, the bearings were worn. I was supposed to have one after 2. I had to grind the crank, so I needed 5 thou there. So I was basically chasing about 17 thou. I was trying to close this hole down 17 thou and keep it in line and make sure that I wasn't going to shorten this distance between the crankshaft and the camshaft. So if anything, the crankshaft should be sitting in the block a little bit higher. I was able to bore line bore the main bearings, and so the tool was just touching at the bottom of the upper shells there. So I think that's gone pretty well. The crank hasn't gone. So basically what I was doing was, what I was doing was I'd close up number 1, tension it all down, bore it, race over. I had the crank and the crankshaft grinder, take a couple of thou off the crank, measure it, race back here, bore another couple of thou, race back to the crank grinder and bring them both down, bring the tunnel out and the crankshaft down till I had 2 thou. Didn't clean the crank up entirely, but gee whiz, it's pretty good. Rear main's fine, centre main's fine, front main has just got one groove in the middle, but in some places it's completely gone, in other places it's just there. So I would have had to go down another, over probably 15 thou to get that groove out. It's a pretty deep one, and I just didn't have the metal. The number 2 main's good and the rear main's good, so I'll put it in now and we'll give it a test. Alright, there it is. Just a shade under 2 thou oil clearance. I will give the crank another lidding, so I'll probably end up with 2 thou oil clearance. Spinning over beautifully. It's that's not taking any more than maybe maybe one foot-pound to turn it over. It's just It's just free as anything. And that's 2 thou. I mean, this shaft started all scratched up and buggered. Had about 12 thou wear in the bearings. So we've closed the hole up, closed the main tunnel hole up, relined it back to a smaller size, ground the shaft down to that size and damn near cleaned it completely up. And now that just turns beautifully. That's no worries at all. Oh, and that's with assembly lube too, the high zinc assembly lube, not engine oil. This stuff's sticky as all hell. So I mean, put just a nice hot light engine oil in there and it'll spin like buggery. So I'm very happy with that. That's really good. Okay, I'm just grinding the crank. So basically what I'm doing is I'm taking some shims out of the small end of the conrod and cleaning up the caps a bit on the rod resizer. Then I'm giving it just to close it down to an undersize. Then I'll give it a run over the rod resizer to try and get the big end round again and straight, but still undersize. And then I can get a size and then grind my crank pin down. This run here I've just finished, it's tensioned up, giving it about 40 foot-pounds tension, and that's got 2 thou oil clearance, and I mean that's just spinning just nicely, nice and smooth all the way around, and it's like there's very little movement there. You can feel it all. It's just fine. That's just good and dandy. This is 1928 Essex. Just finished doing all the big end clearances, main clearances and big end clearances. I was bringing the big ends down about 15. Well, they'd worn about 5, so I had to close them down 5, close them down another 5, so that I was able to machine them back to a smaller size, and then another 5 in order so I could machine the pins down to another size, grind the pins down to another size. So I had to take about 15 thou out of the shims and dress the caps and the parting face of the rods to close the big ends down, and then closed and honed them back to a nominal size of my own choosing. And I chose that by bringing it up a couple of thou, bringing them out a couple of thou to a size, bringing the crank down a little bit, and then trying to work out which was going to clean up best, because I didn't have enough metal to clean both of them up. But in the end, they came up pretty well. I was just able to take about 3 or 4 off the pins and about 5 out of the rods, and that's gotten me 2 thou oil clearance, and they're nice and round. The pins are round, the pins are clean. And while I was there, I thought I'd throw it up in the balance. I put the counterweights back on. I labelled them before I took them off. Put the counterweights back up. Balance the shaft. It was pretty good, but you know, it was probably about 6 or 8 grams in it. And then just put the flywheel up and just give it a bit of a touch too. And it just needed a few little spots there just to get that in balance. So it's not too bad now. It's spinning nice, and it's not too bad. That's the front. That's the back carriage. That's the front carriage. So I mean that's. For 1928 shaft, that's pretty bloody well balanced. So that's good to go. I'll give it a linish up now, and that's the crank and rods apart from a wash, so they're ready to go. This rather peculiar setup is to bore some of the redundant metal out of the sleeves before I put them in the block here. It's a fairly thin casting, so I don't want to put too much stress on the block. It's got nearly 80 thou to come out of the sleeves to get to the 60 up pistons. So I just bore some of the redundant metal out of the inside, just so as I can leave it then to about 1.5 thou interference, and that way I won't be putting too much stress on the block. Otherwise I'd have to put it in with 2 thou interference. I'd lose some of the interference when I bored that metal out. By doing it this way, it just saves a lot of the headache of putting too much stress on the block. As you can see, I'm just doing it in the mill. Try doing that on your rottler. Okay, we're boring the cylinders, boring the parent boards for the sleeves, leaving a step at the bottom, taking it out in about 5 cuts, just nice and slow. The boards are pretty thin, they're pretty damaged, so I'm just keeping the load on the tool light. Not much heat generation, so it's good, coming out well. There it is, sleeves are in. Went in with about 5 tonne, pressed them in, got a step at the bottom of the bore, about 1/4 inch from the bottom of the bore, so the sleeves come down home, they will not sink. No, once they get a few heat cycles on them, they're locked in. So I'll chop the tops, take the tops down, bore them to size, hone them, and that's finished sleeve. Cylinder block, sleeve back to to standard and then plus 60. So shame not to just go back to standard really, but anyway, there it is. We will not have a problem with those bores again. This is an RVR, Repco RVR valve and guide machine. I've lifted the top turret off and put some spacer blocks under it so I could get this side valve block in. And it's a good machine. The head floats on air, so it's nice and frictionless. You line up the pilot, put a pilot in the guide, nice and tight. Come along, line your spindle up on the X plane and the Y plane, and that puts your spindle, your cutting spindle here, puts this cutting spindle on the same alignment as the guide. Then you pop the pilot out and run the tool down in, and then the tools come in various shapes and sizes. This one's just a counter boring cutter, but there's the 3-angle cutters that we use for the valve seats themselves, and that's how you do your valve seats. That's how you cut them, and then we polish them with a stone. That's called synchro seating. That's a counterbore cut. Just rebuilding the little cam followers for this Essex. This is trying to find one that works. This is the cam follower here. This body sits in the block and is locked down, and the roller lifter slides up and down like that. But I don't know if you can see this. The rollers are all very, very pitted. So, and the other thing is the little shaft that holds the rollers in, are very, very worn. Again, I don't know whether you'll be able to see that, but fortunately they're 11/32, and that's the same size stem as Holden and Ford or Chev. So I've cut some little pins out of the valve stem of a Holden 21N-4 stainless or chrome steel valve. So I've got some pretty good pins, and I mean at 2,000 RPM and the about 40-50 pounds spring pressure that's got, I think it's going to be more than adequate. And then once I polish up, I grind and polish up the roller and fit it all back together, all greased up. Make sure all the threads are cleared, make sure the body's all clean, good to go. So I'm just running through them and getting them all set up, and then I'll clean the cam up. Here's the head, every single stud broke off basically, so I'm having to drill and tap every one. A couple of the threads are damaged, so I'll recoil them, and then I'll get that back to good. The old plugs here, they've just completely gone. I'll have to do something about that. Yeah, be wary when somebody says, "Oh, we'll just give it a skim over." Oh, keep in mind this face. The reason I'm doing all this, I want to machine this face because this is actually where the sealing washer for your spark plug seals against. So it's important that we get this nice and flat and straight. Boring out the counterbores for new Welsh plugs to go into the head, because the other ones were just rusted right through. So I'm boring them out to 1 inch and use 1 inch brass cup. Okay. I've just put them together now, so the cam bearings are all in. They're been cleaned up, the location dowels Loctited in. I've put the block the right way up and poured some oil into the feed channel there, and the oil feeds into the cam bearings. I mean you can see it anyway, but I thought I'd do a literal check. Main bearings are in, pinned in and Loctited down. Shims are in. So now I'll put the crank in. Oh, and the other thing is the little splash plates here are in and Loctited in. So they're all good to go, and we'll keep going. Now that's pistons all loaded up. So the crankshaft spins right hand, so as this comes around that'll dip in the oil, a little shooter there, and shoot oil into the piston. Note that the split in the skirt is on the non-thrust side, so that puts this front. I don't know if you can read that there, front. So they're all loaded up, and rings are on, just a square ring, 16th, 5/32, 5/64, sorry. So the rings are all on, 5/64 rings, so they're half the thickness of the original rings, but much more efficient. JP pistons, Australian made pistons and rings. Circlips are all in and checked. Block's all good to go, so we'll put them in now. You won't believe this, I had to pull the crank out again, because all the pistons have to go in before the crank goes in, and go in from the bottom, because the parting face there, or the conrod is wider than the bore. so it can't come down the normal way. So now put the crank in again. Can't believe this. You expect this sort of thing from the British, not the Americans. Alright, there it is. Pistons are in, going up and down as per you'd imagine that they should do. Spinning over just nice. Not taking too much effort. Haven't got the cam connectors up yet. Haven't got the timing chain on yet, but try and get a shot of this. Everything's going up and down there as you'd expect it to. So it's just nice. And this is the bottom end. It's going round and round there like that. Counterweights are all clearing. Everything feels really nice. It's going to be good to go, this one. Okay, there it is. I don't know why everything's orange, but everything's going up and down as you'd expect it to. Finally got all the timing chain and everything on. This idler shaft here is on an offset bush in the back there, and that's how you adjust the chain tension. Chain's a high-vo chain. This is a spring-loaded cam thrust. Sits up against the front cover. Next all good if I can swing in over here. So that's good to go. We'll come and pick this up this afternoon, and 1928 Essex. Full set of sleeves, new pistons, bored and honed, new set of valve seat inserts everywhere, just to give you something to work with. Everything's been surfaced, crank's been ground, bearings have been closed and bored to line, lifters have been re-bushed in the trunnion. Should be good to go. Should run really well. It's supposed to be 18 horsepower. We'll see what it makes on the dyno.